Hello, everyone, and welcome to today's SANS webcast, Everything I Learned and Wanted to Forget About WAFs, sponsored by ThreatX. My name is Carol Auth of the SANS Institute. Today's featured speakers are Serge Borso and Jeremiah Cruit. If during the webcast you have any questions for our presenters, please enter them into the questions window located on the GoToWebinar interface at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to Jeremiah.
Thank you very much for that. So I am Jeremiah Cruit. I'm the Chief Information Security Officer at ThreatX. I've been doing security for over 20 years. Starting out when I was a kid, if you've ever seen the movie War Games, that was basically my childhood. I've done just about everything from network engineering, incident response, and penetration testing. So I've been in the security industry for quite some time, have quite a bit of fun with it, and I'm excited to talk more about WAFs here. We do have a poll we're going to get started right away. Feel free to start that poll. We'll talk about it later on once we get results in from everyone. And I'm going to pass this over to Serge to get it kicked off.
Hey everybody, my name is Serge Borso, and today we're going to be talking about web application firewalls. So briefly, just about myself, I'm a SANS community instructor with over a decade of experience in information security or cybersecurity field. I operate an information security consulting company. We focus primarily on providing penetration testing services and some security awareness training solutions as well. As a consultant working on the red team, I have the task of identifying, flaws in PCI networks or mobile applications or physical buildings and trying to gain access to these applications and networks as we see fit. Part of the process of doing this, though, really involves understanding the business I'm working with, their products, services, culture, expectations, and a large portion of what I do requires technical expertise, to actually be successful and provide value without causing harm. And like most professionals, I also have a desire to innovate and get better. So with that, I'm going to share my knowledge and experience as it pertains to web application firewalls and have a lively conversation with Jeremiah on this topic and hopefully provide some value to each of you today. I've been dealing with WAFs for quite some time over a decade of experience, and I've seen some good ones, I've seen some bad ones, I've seen them provide some great value to organizations, and I've seen a lot of companies not embrace the web application firewall. And we'll talk about all that stuff as we continue throughout the conversation today. So for the agenda of what I want to cover, got a little bit of background on the problem that these firewalls are trying to provide a solution for. I'll talk a little bit about on web application firewalls as far as my knowledge goes. Talk about how they work, features, everything you see on the slide right there. But what you should know is, typically when I do a webinar with SANS, it's for like the last stage of a product review. But in this case, I'm going to, I'm kind of going in with limited knowledge in terms of ThreatX and what they provide. So it's a little bit different context for me. I haven't researched their tool, their product for the last 3 months and talk about it now. So it's kind of nice going into it with less information so I can learn something too from Jeremiah, and we can have, like I said, that dialogue and share some knowledge with all of you listening in on this. So you can read the slides here, but basically I'll talk about some of the issues with WAFs, try to solve how to go about doing this. There's a lot of potential value when implementing this technology, but like most solutions, if it's not implemented to 100% and tuned and updated, then it's not working arguably as well as it could or should be. And I've seen a lot of instances where you go to implement an IPS or a WAF or some next gen whatever, and it gets implemented to like 80 or 90%. What I mean by that is you have this device in line and it's listening to traffic, and you're watching all the different requests coming into your web applications, and like, okay, cool, we've completed these couple of hurdles or these couple of required components to saying we've implemented this technology, but the SSL decryption module isn't in place, or it's not working right for all the applications. Or, the list kind of go on. It's just maybe not listening to all the segments, or you have it in listen only or learning mode. You're not actually blocking anything with it yet. And a year later, it's the same case. You've implemented some TLS or SSL decryption, so you actually can see the payloads of malicious traffic, but you're still just learning. And it's like, well, we're learning because we're going to update it to the new version. So we're going to keep on having this tool in learning mode. And it just stays with that pattern for quite some time. The problem, though, that I see web application firewalls trying to address is this question right here. How often are applications being attacked? All the time. That's my little picture in there. Anyway, what we're trying to actually protect against are web application, layer 7, OWASP top 10 type of attacks. So we're talking some dictionary-based attacks, people trying to brute force their way in. We're talking injection, of course, like SQL injection, maybe some denial of service, cross-site scripting, some of the OWASP top 10, where we have the ability to listen to traffic coming from endpoint to endpoint, the user's browser or the attack tool like SQL map, or whatever tool the attacker is using, all the way to the web server. Or in this case, with a web application firewall, where TLS is being terminated. So typically on the WAF itself, where we'll stop that, we won't stop it, but we'll listen to that traffic, decrypt it, inspect the payloads, and try to address this problem of constantly being attacked. Anything from obviously the Facebook example, which is brand new, just happened, to Equifax, to Heartbleed, to you name it. We're constantly under attack. We in the industry know this, so we got to figure out some solutions to this. And one of the solutions that we've come up with over the years is this concept of a web application firewall. There's other stuff we're trying to do here, parameter tampering or making sure we have normalization of data. There's a bunch of stuff, a bunch of different attacks and maliciousness that happens at that layer 7. There was, I think, a Gartner study that said 70+% of the attacks are at the application layer. So very, very common platform to be attacked and for abuse. The solution, this web application firewall, you see it come in a couple different forms. So a signature-based, typically, you'll see this for IPSs as well. And what they try to do, a lot of web application firewalls out there that I'm familiar with, are match signatures. So kind of going back to this learning mode, this concept of learning mode, where we'll have an application firewall, and what it's trying to do is understand what's the baseline. What does the typical, normal, legitimate inputs look like for an application? And when we are in learning mode, the web application firewall can monitor that traffic, inspect the payloads, and say, well, based on this form field or this cookie or whatever the input happens to be, these HTTP headers, this is normal. This is the baseline. This is what typical people would do when they browse this application, authenticate to it, and interact with it, and upload files, and change their profile, and make transactions, and so on and so forth. This is what normal is. This is the baseline. So when we see something that's obviously outside of that norm in terms of someone logging in with the first name of single quotes space or 1 = 1 semicolon, it's like, okay, that's so far outside of the norm. We have a signature for this. This is obviously some injection attack, a SQL injection attack, and we should be doing something to block this. So what a web application firewall does, it basically works like an IPS, but for firewalls. An IPS, an intrusion prevention system, essentially does the same thing for networks, where there's a signature, a known quantity of maliciousness, like a blacklist. This is malicious, and we need to block it if and when we see it. For a WAF to be providing value, we have to be decrypting SSL and TLS. And I touched on this briefly a moment ago, where I'm saying, no, I see businesses implement this solution to 90% or 95%, or at this case, maybe 50%. If they don't have the tool inspecting that traffic, that encrypted TLS traffic, then that tool can't inspect the payload. And it kind of harping on this here, but I still see businesses where this isn't implemented properly, or it's not done 100%. So that's a big piece of this, is providing that value. You have to be able to inspect the traffic to block it. And the next thing, of course, is blocking malicious traffic or alert on malicious traffic. There's certainly a lot of value that this tool will provide for a given institution or a given organization. What we want to focus on is basically setting it up properly. It has to be tuned. The big thing here is tuning to the environment. And I talked about learning mode and training the firewall in terms of what is normal or what's legitimate data. But we really need to make sure that as the application goes through the SDLC or DevOps or whatever cycle we have to release new code, that as new input fields or modifications to the application are introduced, the web application firewall is staying up to date with this in terms of, once again, what's the baseline, what's normal, and how can I alert on deviations from normal. So the first thing I set up here is signature-based. Typically, you will see, signatures. What does this traffic look like? And if it looks malicious, I'm going to drop it. But there's other ways you can do this as well. And I've been introduced to a few different solutions that do it in a different way. And Jeremiah will go way into more depth on what other things we can see there. But it's not just signature-based. There's other interesting things we can leverage. And I said, signatures, rely on signatures. What does an injection attack look like? What are these strings? That's really what it comes down to when we're talking about trying to block traffic, or at least alert on suspicious activity. It comes down to what strings are being submitted to the application, and what can the web application firewall see, and what can it determine is the deviation from the normal. Other things we have to think about, or at least know, as far as web application firewalls, is the actual technology itself, what platform it is. So we have hardware, like a physical box we can go and buy. We have software, cloud-based, in AWS, for example, where the actual web application firewall itself is just some software or a service that we purchase and turn it on, and it starts needing to be tuned immediately so it can actually provide some value. I also mentioned learning mode a moment ago. There's typically some profiles or policies or some type of default template that will come installed with many application firewalls. This template, what this tries to do is have a list of known attack strings or known malicious inputs that it should be filtering out. So if and when the web application firewall device sees that traffic or that payload in a post request or get request or whatever request it happens to be, they can go ahead and say, based on my templates, my profile or this policy I've implemented, this is not an appropriate input for this application. And maybe you have a bunch of PCI type applications, or a bunch of things that are required for HIPAA, or a bunch of couple different applications that require certain inputs in certain form fields, like a login page, or different components that require other types of user-provided untrusted data to be submitted to it. You can create a certain profile. It says, based on this grouping of technology, this grouping of devices, we should be blocking this illicit traffic or this injection attack or whatever happens to be, given that technology or the web application in the back end. So the policies work essentially like that. What you want to do is essentially understand what is malicious and how to stop that. So the way you test for this, and the other big thing about how this works, is you want to make sure that as we're going through and setting up a WAF, or even we have a WAF in our environment, it has to be tested for. And a big part of my experience doing penetration testing is often a conversation about where or what we're focusing our efforts on during a web application penetration test. And what I mean by that is, during the conversation with the business or the entity that's requesting or requiring the web application penetration test, the question arises, should we have, number one, credentials? Number two, are we going to be situated in such a location logically on the other side of the internet where our traffic will be flowing through your firewall, and will be flowing through an IPS, and will our traffic also be being filtered by a web application firewall? And if so, what are we really testing at that point from a web application pen test perspective? If all of our traffic is being filtered by devices specifically tuned to block malicious attacks, are we testing how good the filters on the WAFs are, or are we testing how good the sanitization is on the backend application? And that's a real legitimate conversation that has to be taken into account. For this conversation, obviously we're talking about the WAF itself and tuning it and locking it down and making sure your profiles are set properly and it's learned and it knows what is malicious and what's not malicious to the best of its ability, which is not an easy thing to do all the time. But now we're talking about how we actually test for it, and what happens if you're not staying up to date with tuning your web application firewall. Can I, as an attacker, use that to bypass it? And it happens all the time. You see web application firewall bypass and evasion techniques, even built into tools. I mentioned very briefly the word SQL map. SQL map is a SQL injection Python-based open source tool that allows attackers and legitimate penetration testers alike to actively try to inject SQL statements into web applications. Within this tool, there's built-in evasion techniques that can help obfuscate our data to bypass some web application firewalls, whether it's a physical appliance or whether it's software-based or whatever the case may be. So this is basically how they work and how we try to set them up. The features here of web application firewalls are going to be, custom rule creation, so we can basically create any custom rules we want to for a given application, as some of the profiles or templates that come out of the box when we purchase our software, this web application firewall, hardware or software, the case may be, may not be specific enough to our environment as to provide value right out of the gate. So we can obviously create our own custom rules and test that out. API integration, of course, is a huge one. Virtual patching, this concept of, okay, let's say our application has a known vulnerability, it's been published, there's exploits happening for this. I don't have time to do a bunch of testing. I don't have the time to thoroughly implement a fix at the source code layer for my robust application that millions of people are using. I can't do that in a timely manner. I have time, and I'll dedicate it to doing so from that perspective of it has to get done. But in the meantime, I need to virtual patch. I need some type of solution that's going to sit between the attackers and my application that's going to block these malicious attacks. And this is this virtual patching concept where I can get that patch installed in the WAF itself, which will protect my application until I have the time it takes to adequately roll out a new release of my application and test it and make sure my fix didn't break something else, make sure I don't have any more vulnerable components I'm using in my libraries and so on and so forth. Because it takes time and effort to release a robust application that has many different users. It's tough to do. Device integration, you'll see this. I'm just touching on this point here just to know that there are some technology solutions here for WAFs and IPSs and next-gen firewalls and load balancers, all in one type of solution. Personally, I don't typically tend to focus on this as a great solution, depending on your business and depending on the size, requirements, and budget concerns. Sometimes one device that does it all is ideal, and you still got to buy two of them though for redundancy. Other times you have a large organization and you need to have other things taken into account in terms of the scalability and redundancy, and I don't want to say quality of the tool sets, but I typically see larger businesses going down the path of having different devices dedicated to different things. So a load balancer is not the same box as the firewall. It's not the same machine that does the intrusion prevention system. It's different than the firewall. It's 4 different things as opposed to one device that does it all. Other things that we want to talk about here, of course, are the concept of custom logging. And logging is a huge thing. So maybe you have an application that simply wasn't written in such a way when it was first created to enable enhanced logging. It doesn't know when it's being attacked. That's a huge piece that a web application firewall can kind of fill the void for, where not only will you get logs on malicious events, you can also get usage statistics. And a great example of this was when PCI came out with the directive to disable TLS 1.0 and 1.1. And it's like you have till June of 2017, 2017, to disable these protocols because they're no longer be PCI compliant if your application supports TLS 1.0 and 1.1. Well, with a WAF and enhanced logging enabled on this device, you can sit there and listen and say, okay, what different handshakes is my application making or my web application firewall making when a client connects? And with that enhanced logging, you say, well, if I were to disable TLS 1.0 and TLS 1.1 and only allow TLS 1.2 or 1.3 nowadays, I could say that based on my statistics and my last 2 months of looking at logs, I could say that the clients that are connecting all support TLS 1.2. So if I disable 1.0 and 1.1, it shouldn't cause an impact. This custom logging is a big piece, which I'll touch on at the end of my conversation here as well. But of course, like anything else, this isn't a silver bullet. You can't just go buy a solution, make a purchase, and expect it to stop all attacks consistently. You still have to tune, update, fix as new vulnerabilities come out. That's a huge piece of this. And of course, I always go back to fixing the root cause. So the value add piece to this, the web application firewall, kind of what the value add. So a long time ago, several years ago, I pitched the idea and actually did an OWASP talk on this in Denver several years ago. And I had this whole slide deck all laid out, and I said, okay, here's my idea, and here's how I implemented it. And what it was this concept of basically having the application, your web application, defend itself. And the notion here was an application layer defense mechanism. So the application code base was basically smart enough to know when it was being attacked. It would maybe profile, kind of behavioral based. It would profile you as a user. And it's interesting. I thought it was interesting, at least that's why I did a talk on it. In the concept of, okay, I can assign like a score based on what you're doing. I can check your user agent. I can check to see if you have cookies enabled. I can check to see if you have JavaScript enabled. I can check to see what you click on. I can check to see how fast you click, how quickly you interact with my application. I can check all these different client-side components in terms of, like I said, your user agent and how fast you're clicking on stuff. And I can use this to score your session, score in terms of risk. What risk score would I associate with your session based on the fact that your client doesn't support JavaScript? Okay, that's highly suspect. Okay, most of us don't use NoScript, and most of our browsers have, all of our modern browsers have JavaScript enabled by default. So when a user goes to visit this web application and they don't have JavaScript enabled, okay, that's suspect. It's not suspect enough for me to kick you out, so you can't use my application. But I'm making a note of that. I'm giving you a risk ranking or a risk score associated with that. And this is more of the behavioral-based approach that I pitched. And if you look at the second bullet point here on the slide, it's like, yeah, okay, I talked about that years ago, but I've never seen anyone do that ever in a robust, mature organization. Small mom and pop shops or my own personal web applications that I write for my own use cases. Yeah, I do it, but I don't have millions of users. So I've never seen that actually done. It'd be cool. I think Jeremiah probably has some good comments on that when he talks about his portion of this. To go down that behavioral-based approach and have that risk ranking and see what is suspicious, profile the user, not just signature-based of what are you sending to my application, but more of a behavioral-based of how are you interacting with it and how does this conform to other users or maybe your visitation in the past. So why not have the application defend itself? Like I said, you got some issues here. It takes time. It takes money. It's complex. You have to maintain it. You have to document it. You have to update it. You have to do something with it. And I don't see a lot of businesses or developers being in the business of wanting to implement some type of solution like this at the code base level itself. I see it much more likely to be a purchase that you make, some technology that you buy in the hopes that it will provide this value for you. But not always easy to do. The other thing I want to talk about here is technological progression. So yeah, I had the idea of behavioral-based application defending itself. I haven't seen anybody really do anything quite like that. And it could just be my own ignorance. I'm not saying no one does that. I'm just not really aware of that on a large scale being done. What else can you do? You can pay for the solution that's not 100%, and it never will be. Yeah, and what I mean by that is there's no, like I said, silver bullet for this. You can't just go and buy some software or buy some piece of hardware and expect it to work. Or what else? What else can we do to help lock down our application, keep getting attacked without web application and firewall protection? Or is there some better way to go about doing this? So where does this actually leave us as an enterprise defender or as someone responsible for web application security? Well, we kind of have to go back to the basics here. Secure coding, if we have any control over that, or local WAFs chapters or SANS training to make sure our developers are up to snuff with secure coding practices, and then layered security. But part of that layered security, honestly, is a web application firewall. When I go back to the PCI example, simply because I deal a lot with PCI and the PCI penetration testing, and that's a lot of what I do for my clients. You look at PCI DSS 3.2, section 6.6. You have to do an application security review for your application if you're going to be PCI compliant. So if your application handles card holder data or PCI data, they need to be doing a web app pen test every single year, unless you have a tuned blocking web application firewall. It's kind of a little caveat, a little out there for you, so you don't have to do necessarily, the way I understand it, a web application penetration test if you have a WAF up and running. Now, I also threw the word, the little caveats in there of tuned and blocking. you can't just have a WAF, sitting there in learning mode, not actually blocking malicious traffic. It has to be properly set up and providing some value to the organization as it pertains to securing the application. So this layered approach is still very real. What we have to start thinking about now, this technological progression, is what is the best solution for this job? We still need to have all those different technologies in place, from a firewall to an IPS to IDS to web application firewall to secure coding to so on and so forth. Vulnerability scanning, pen testing, all these come into play. But when we're talking about moving forward and switching from maybe signature-based to some newer, smarter way of going about protecting applications, that's another conversation we need to be having. And there may be some new technology. And I think with that, I'm going to stop and hand it over to Jeremiah, and we can continue the conversation about maybe what this might look like.
Yeah, thank you much. And definitely a lot of points very relevant. One of the things I want to say is that we're really seeing lots of problems with WAF in the marketplace today. They're really not keeping pace. More people are putting more types of applications on the internet. We, have as many different applications as you count, and now they're all being accessible everywhere. So it's really not keeping pace. It's difficult to manage. You talked a little bit about tuning to an application and whitelisting. I love the concept of whitelisting. I think we've always loved it for just about every type of application imaginable, including whitelisting in an environment of all executables that are approved. But it's such a difficult thing to manage, and it breaks so many different aspects of pages and requires complete integration with your development process. So, with that whole integration, you really just have serious problems with maintaining it, keeping up to date. It's one of the things I see making web application firewalls fail more and more, people trying to get into that type of model. You talk quite about a signature. There's a time and place for signatures, but really, if you are, loading up thousands of signatures, you're going to have a ton more false positives. It's going to detect things that are not there. But what's really worse, it's going to have many false negatives, right? It's not going to detect the actual attacks that are trying to evade that. Attackers know exactly what you're looking for. And so, if you are looking for, exact SQL strings or other SQL injection attacks, you're going to miss it. And really, so looking for components of that in a behavioral-based risk approach that's looking at the attacker makes a lot more sense. And then I think the biggest problem we see with WAF is no one knows how to run them. No one wants to run them. To have those actual skills with web application, you need to be specifically trained. You need to be focused on it. We see a lot of times where companies, and my last companies are excellent examples. Does the network team run it? Does your security team run it? You have people on either of those teams that understand web applications. It becomes this sort of kick the bucket down the road. Who's going to run it and who's going to maintain it, and it ends up not doing anything, which is a serious problem. I think what you see out in the marketplace is, this is from Ponemon, but we've got a lot of companies that are using a WAF. They have it set up, they have it configured. They don't have very many applications configured. They may just have one application, and they're missing every other web application they're running. So we see a ton of companies where they have a single application with their WAF looking at it, and none of the other applications are. And if you know anything about attacking a company, doing a pen test, you're looking for those other applications. You're looking for anything else that's your environment. And so not protecting all your applications is one of the biggest concerns I see out there. But I really also just see so many WAFs out there that are not configured at all. They're sitting there listening, they're learning. They may have a couple of blocking rules in there for virtual patching reason, but they're not put into blocking mode, because as soon as they put them into blocking mode, your application owner comes down and says, you're blocking good traffic, we're losing business, there's concerns, and you shut it off. That happens time and time again. Or if you're using full signature base, you start reducing the level of signatures you're looking at and starting to eliminate signatures and saying, okay, well, this one keeps firing, so I'm just going to shut it off. that just weakens your entire protection again and again. It's a continual problem that we see. I've seen it all over the place. And as you said, these are still being attacked significantly. All your web applications are. We see web applications getting attacked constantly. Obviously, we're a web application firewall. We're looking at thousands of sites, and so we're seeing all these attacks all the time. We don't have a single site where we don't see attacks coming on constantly, whether it's bots that are scanning, trying to do password stuffing or other attacks. We see people shifting their attack patterns, so coming in and then coming from a different IP, coming from different systems and domains, and just about every kind of potential attack, we still see a ton. I don't think that there's any types of attacks that are going down at all. I think that the same web application issues we've seen for the past 10 years are still the same web applications we're seeing today. So hopefully training will improve that, but there'll always be new types of attacks and new types of methodologies. So it's definitely something we continuously see as a problem. We're seeing more and more of this every day. And of course, I think what you'll also see is in the news, we see a ton of different attacks happening. We've seen, you mentioned Experian. That's a great one to talk about. I don't have that one on here, but the Experian attack was all web-based attack. And then we just got some recent information on it that after the attack was completed, they used another one of the websites for all the command and control traffic and to exfiltrate that data, right? And they weren't looking at that other website. They were apparently had a expired certificate, or they didn't have the proper key loaded to actually look at that data. And so they missed it completely. So that's another great story of yet another application in the entire suite was actually used to exfiltrate data and do your command and control. So if you're not looking at all your applications, you're really missing a significant portion of the attack out there. Let me see here. And so you talked a little bit about this. What do we really need to get around these problems? How are we going to actually solve the issue? We need to have something that's actually learning what's good, what's bad, not really using those manual signatures except for maybe specific purposes, but basically looking at segments of it. So instead of saying this signature needs to look exactly this way, you say, I need to see these different components in it and to build up a risk profile. So that risk profile that's looking at that attacker and assign it to an attacker to say, I see this happening, I see that bit, and I see that. I'm going to add all these different components together and block them. If I see just one or the other one, I'm not going to block it. I'm going to assign risk. I'm going to watch them further. The next thing they do, I'll start blocking them. But if I'm only seeing small components, I'm just going to add that to that attacker. And that really helps especially reduce false positives. So what we see a ton out there is these signatures that, because you want them to be effective and you want them to stop the attacks, they get overzealous for what they're looking for, and they match, more things than they should. That's a constant problem why the things get shut down. So WAFs will get shut down as soon as you have false positives. And of course, no one knows what the false negatives are that they're not seeing with that. So as soon as they stop turning off signatures, they're missing all of this entirely, right? So they're not seeing the attacks that are coming through. They're not matching against it, and they're not knowing that bad things are happening. So those false negatives are a huge problem. And obviously attacks are changing every day. You can't possibly keep up with every single attack that's happening. We have a SOC that is looking at this 24/7, looking for new types of attacks and validating our systems or detecting them. But most companies don't have that luxury to have that. But even so, there's always new types of attacks. And if you're looking for things that look like an attack with that machine learning, with that analysis that's going on, you can actually find those new attacks, those 0 days before they come out, because they look suspicious. And while you wouldn't normally block them immediately you might say, this looks like a suspicious attack, and say, okay, they also did a few other things, and then we're going to block them. Or at least identify that new 0 days coming out and identify it. So it's definitely much better to actually do behavioral based, looking at the attacker and really learning what's good and bad, rather than relying on specific signatures that are static, only looking for one type of attack. And then if you can engage those attackers, so if somebody starts attacking them, if you can start injecting false fields or basically trying to see if they're a real system, giving them false data back, really what we call active deception. You start looking at they're attacking. Well, let's see if they're really a real person. Let's see what they do with this. If they start reacting to those things that we inject, we know that they're worse. And so again, it's about assigning risk. Like you mentioned, having no script turned on and not being able to do JavaScript. Well, we just add that as a risk, right? This is a slightly odd user. And maybe it is that one user that's running no script and really they're just like one of us security people who are concerned about what's going on, but maybe they're an attacker. It's a good indication of it, but it's not the only indication. If I block everyone that doesn't respond to JavaScript, I'm going to be blocking customers. I'm going to be blocking my users of the application, and I'm going to get my WAF shut off. If I take that as one point to look for and add it to a risk store, then I'm actually doing quite a bit of better job, and I can look for those oddities. And as soon as they do more things after that, then I can start blocking them. And of course, you need to look at this over time. We keep talking about the kill chain and watching them to start with. So if we see somebody starting off and doing reconnaissance and scanning, we're going to watch that. We're going to assign scores to that. We're going to fingerprint that system and keep an eye on it. We assign clever names to all of these different entities that are coming in, but then we track that attacker. So we're looking at the attacker coming in and we're seeing that. So that is absolutely vital to be able to see the period over time. So not just one event that you're going to block, but what did they start doing? How did they progress? Did they start looking for weird pages? Did they stop responding to JavaScript? Did they do these other things? We just keep adding risk up, and then we'll normally block them before they even get to a real attack. But if we see that real attack and they haven't had much risk, we'll also block that. So it's a great methodology to actually look at that. And so I think that's what any good next generation WAF should really have. And of course, you need to support everything, everywhere, at any time. So wherever you happen to have the application, whether it's in a microservice, if it's basically containerized, if you have to run it in the customer environment or you run it in our cloud or somebody else's cloud, you just need to be able to run anywhere. Support every type of architecture. Be compatible with DevOps so it can be deployed instantly and taken down instantly, and scale infinitely, right? So you need to have all these capabilities in next generation WAF. If your WAF can't keep up with your website load by scaling immediately, then you've got a serious problem. And I think a lot of the older solutions out there, obviously, appliance-based or license-based, where you have to say, I'm going to run this specific many. If you can't scale those infinitely, you're going to eventually have your WAF not keeping up with your website. It's also important when you're getting attacked with a DDoS. You need to be able to expand infinitely to capture that DDoS traffic and start blocking it before it gets to your web application. So obviously, all important.
Hey, Jeremiah, I got a question for you.
Yep.
As far as next-gen WAFs go, I'm thinking, okay, so we got actions we can take. Next-gen WAF should be, watching that traffic, going to behavioral analytics on it, and then instead of maybe blocking the known suspicious traffic once they've identified a pattern of maliciousness, what are your thoughts on sending that malicious user to a sandbox honeypot environment instead of blocking it?
Yeah, and that's what we talk about when I say actively engage them. So we start seeing them, we can actually start to inject, new fields or, have them, if they go to, a password file or, they look at password, we can inject false values in there. And so that active deception basically is what you're talking about there. So we can actually engage with them. And you're right, that makes it a lot better. And then, once you start fooling with them and you start having them not actually attacking the application, but they're in your your environment before it's sent to the web application, you can start to say, okay, well, let's let you do some very malicious things and see what happens, right? So you're right. That's a fantastic feature of any new next generation type of WAF. All right. So again, I've kind of gone through some of this, but we really need to be able to identify exactly what these attackers' traits and behaviors are. So that attacker-centric view is key to everything that we do, and what we think every new WAF out there should be doing is basically looking for how that attacker is behaving over time, and really, looking at them in that kill chain approach. So as they start off and as they go to further and further up, tracking them and attacking them, so that, really learning what they're doing and learning how they're doing it so we can attack it across all of our customers, that's extremely valuable. So we see the model that attacker is doing against one customer. We can say, okay, we see them start this way and then they go up further and further. We block them at this point. Well, now we can learn from that. So with machine learning, you can actually learn that behavior and say, okay, well, if I see this same exact type of attack, I can block them earlier and earlier. Still making sure we're not blocking anything good, but when we see a good behavior, we can learn it and we can look for it in the future. We can also look for what's normal and good traffic and just say, okay, what is abnormal and odd. So after we've looked at a site for a couple of days, we can then actually start to look and say, okay, these things are slightly outside of normal. And we do that with, again, that risk-based methodology. So looking at a risk for that is so much better than saying I'm going to block anyone that's doing anything different than what is normal. So if a website changes, they update their fields, as it progresses, if you're looking at a risk-based, you can say, okay, this is a little bit of risk that we're adding because they're doing something differently. But then as that becomes more normal, that risk starts to reduce for that. So that sort of give and take where, applications can change and we can adapt with them without having people have to do anything on their side. So, this is one of the things that I think is one of the big things about ThreatX is that we're able to do this sort of effortlessly for their customers. They didn't need to know about the new struts vulnerability that came out. We automatically patched it, validated, and could clean that traffic coming in. So we can see that anything coming in attacking in that methodology, we can detect it and stop it. None of our customers had to do anything to enable that or get that running. It was automatically deployed and functional. So that learning and identification is absolutely vital. And again, actively engaging those attackers, that's a super valuable feature that really gets to know, is this a real user? Is this an attacker? And that methodology is extremely useful. As you mentioned, giving them some place to play and detecting what they're doing and then blocking them is a great feature. And then fingerprinting them. So I think one of the things I mentioned is that we need to attack that track over time. And so we have to have good methodologies for identifying that attacker, both from a behavior-based methodology, but also from standard fingerprinting methodology. Say, okay, I can see them. I've given them a cookie, or I've given them, I've tracked them in different ways. And so I can see what they're doing over time. And so we can see those attackers going across everywhere. So we can see them attack one customer, and then that same attacker, we can see another one. Once we've seen that, they've already gathered risk. We've already given them a risk score based on attacking the first customer. When they start going against the second one, we can automatically block them. So being able to share that data across and track those attackers is truly impressive. And so again, that attacker-centric approach, low false positives. So we have so few false positives in our environment. Most of the false positive tickets we ever get are we're seeing somebody scan our site, and it's a search engine optimization that we paid for, so it's approved traffic. But when we see it, it's obviously bad, right? So we're seeing the bad things it's doing. We see it's crawling across the site, and we start blocking it. So implementing something like this, you need to make sure, if I have something that's scanning us for approved reasons, we can whitelist those, obviously. And it's, I think, a great thing to say, we're not going to whitelist pen testers. So, you scan websites all the time. And I think it's great to basically still have all your defenses in place and watch what the attackers are doing and see if this is an effective control to stopping attacks on your website. So I generally don't say we should even whitelist an approved attacker. But really, that low false positive, fantastic, because people can get things into blocking so much quicker. So if you have a lot of false positives, you're going to have to dial back getting into blocking mode. Our customers get into blocking mode within a couple of days. We basically can fingerprint and validate the site. We can go through and make sure that you're not going to have any false positives in that first couple of days for any moderately busy site. So if you're sending traffic to it, we can identify it and start profiling it. If it's a very unused site, then it takes a little longer, but we can do that in an automated fashion, looking at those attacks coming in, looking at what normal traffic it is, and start to validate and start blocking because of this attacker-centric approach. It really allows us to get into blocking mode extremely quickly. And I think one of the other things you mentioned is that constant tuning of a WAF. It's one of the problems that I've had in my past dealing with any web application firewalls out there is constantly updating those rules, updating it when a site changes, validating what's going on. If you could not have to do any of that, you could actually have a WAF that is constantly tuned, constantly blocking, and actually doing what you're paying money for. So that's one of my biggest concerns when, as a CISO of my previous company, is that if you're blocking these types of attacks, it's causing you issues. It's causing impact to your revenue streams, and you have to dial back what you can do. And so you basically have to go back and turn it off or reduce what it's doing. So, having to have somebody tune it constantly, sometimes what they're doing is tuning it down and down and down, so it's doing less and less and less. It's blocking less things. It's not impacting your application, but it's doing less and less. And then, not having to actually investigate every single different things that you see. So if you don't have it in blocking mode, you just have it watching, you have to go in and investigate. Okay, is this a real attack or is this not a real attack? What is actually going on here? And so without having to actually go in and investigate is a huge benefit of going to, say, a managed service platform where we see a block or we see an attack, and we can go in and actually look at that and validate it, make sure it's appropriate, and take action on it. So, having somebody else be able to handle that as a managed service is a fantastic solution, but also where you have a system that's doing this machine learning, it's automatically adapting. You don't have to do quite as much of that at all, which is a true benefit. And then, as I said, a platform that can go anywhere, right? So if you can't deploy a WAF to, protect a custom application, you can't deploy it within a customer environment, or if you can't support any different cloud environment, any different deployment model, whether it's Kubernetes or any other type of methodology, you really, aren't protecting everything. And again, going back to what we said in the beginning is, most of the attacks are happening on tertiary websites, other websites you have, but you're not watching for. And whether or not you're not watching because you don't control the application and so you can't install your particular WAF in there, or it's in a special environment that can't work with the cloud provider, whatever the case is, if you're not protecting everything, you're leaving yourself open to risk. And so getting a WAF that's truly able to be deployed anywhere in any methodology, full integration into DevOps model. So we're all Docker container based, so we can deploy any way you want to, anywhere you want to. You can deploy them quickly, efficiently. You can tear them up and take them down and just deploy them however you want. I will tell you that most of our customers decide to deploy in our cloud just because it's so incredibly easy. A DNS change and uploading your keys, and you basically are in protection mode. So it's incredibly easy. A lot of our customers start out that way and never leave that way, just because it's all fully managed by us. Another great model with that is you're pushing the risk further out from your environment. So if you're running within our cloud, all the risks are attacking us. If you're getting attacked, denial of service, it's all happening in our environment, and we can protect and filter and restrict at that zone. So it's not affecting anything else in your environment. So That's a truly important distinction. Is that ability to go absolutely anywhere you need us to be. I think is truly vital. So I'll click through these things. This is basically, our model, right? And I think it's the model that any next generation WAF really needs to get to. But being able to do everything in any place is fantastic. All the data that we have collected from our sensors that are pushed anywhere comes back up, is analyzed by what we call our hacker mind behavior analysis engine. It's doing that machine learning. It's doing that analysis of those attacks. That's all hosted in our data center. It's all managed. We're only getting metadata sent up to us. So customers that are concerned about what type of data is going through there, we're really only looking at the metadata. We're only looking at the basics of what's getting attacked. So we're seeing the types of attacks. We're seeing the attack command and argument, but that's it. So we're not collecting any customer data or anything else in our environment, which is fantastic from compliance standpoint in other areas. I think we're going to move on to questions now. And do we have any questions here?
All right, yeah, thanks for that great presentation. We do have some questions ready for the Q&A. However, if anyone has a question for our presenters, please enter it into the questions window now. Our first question is, can you give me an example of a threat that an attacker-centric model would block that a signature-based model would not, and vice versa?
Yeah, so there's a lot of different attacks that attacker-centric, risk-based, and behavior analysis will attack as, attacks where really they're trying to evade detection, right? So when you're trying to evade detection, you're either doing encoding in your attacks, you're doing different methodologies to hide the different components of it. Because we're doing that risk-based and analysis, we see this is extremely different than any other type of request that we see. We see the encoding, we see the different components. We add all of those different components up to add to enough risk to block. Whereas a static is going to be looking for a specific type of query, or specifically, I've seen this in the past and it's bad, so I'm going to block that. Vice versa. Signatures are not all horrible, right? So if you know very specifically that this is a attack that is exactly the same every single time, there's no false positives, there's no way for it to be a false positive, you can definitely deploy a signature. And we have done static signatures in our environment. We tend to take that static signature and then convert it into some way where our automated platform can detect and block it. But there are benefits to signature as well as behavioral. But obviously, if you only rely on signatures, you're going to miss a ton of attacks, and you're going to block a lot of good traffic. So there's issues with only ever relying on signatures. But if you only rely on the signatures that are extremely accurate and very targeted to a specific attack, you're going to miss everything else. So that's, I think, the benefits of looking at it from more of a risk-based, attacker-centric methodology.
All right, thank you. I have been using a signature-based WAF my entire career, and I'm hesitant to make the change to a new tool. What is the burden on resources to make the switch?
So most companies we've dealt with, the burden goes down significantly. So we obviously have our own 24/7 SOC that's looking at these attacks for you. We can build up signatures if you specifically have them. So we have a team that can build them, implement them, test them, and validate them. Generally, most companies, their burden on running it goes down significantly. One of the things that I like to call it is effortless, right? So we have a team that is doing all of this for you. You don't actually even have to manage your WAF anymore. You don't have to go in there. If you have a signature you want to implement, you can just email us and email it to us in real normal language, and we'll convert it to a signature, validate it, test it, and put it in place. We're also looking for all those new attacks. And so this is everything we do. This is 100% what we're focused on. So, when some new attack comes out, we're looking for that. We're building those signatures and we're deploying it. So, with the new Struts attack that came out, we had a signature out for that in a few hours, deployed to all of our customers. they didn't have to do a single thing to implement it and be protected. So they had the time, the luxury to go and patch at their leisure. I definitely say you should patch. I'm not telling people to not patch. Again, it's defense in depth. You should definitely have, all the layers. You should be validating your code for security. There's lots of different things you should be doing, but having a WAF that is well-tuned, is reactive to new attacks, and having that in place helps you not have to worry as much and react as quickly. So you can say, okay, new thing came out, we're vulnerable to it. We have the WAF that's protecting us. We can validate that, and then we can patch in our normal patching cycle. It definitely takes a lot of the burden and risk off of our customers.
All right, thanks. I agree that whitelisting requires building the requirements of a safe application into the development process at the requirement stage. Why is it so hard to convince IT management to include this in SDLCs and develop training?
Well, I would say that's because of the time and effort that it takes. So if you have to embed yourself in the development process, and now you have developers that either have to be managing and updating and working through that, you definitely are going to have problems just with resource constraints. And then, it's really really not the developer's job to protect the web application. It's their job to write secure web applications, right? So having them trained and focused on securely developing code rather than integration with a WAF or another area, I think is maybe a faulty design. Really taking it out of there so that all they have to do is focus on developing secure code. And if they make a mistake and vulnerability is written into their application, well, the WAF is there to help protect them from that. And we can detect it. We can let them know, hey, we're seeing this particular issue and vulnerability. Somebody's attacking it. You may need to look at fixing it. So you want to have multiple layers there. Secure coding is absolutely vital, and making sure that your developers are doing that. But having that second layer of defense of a WAF is truly important. I will say that I've tried to deploy whitelisting-based WAFs, and it is extremely difficult. And that whole integration with the development lifecycle causes issues and outages, QA problems, and testing validation issues. So there's a lot of issues I see with that complete whitelisting approach. I love the concept of it, but it just is horrible to implement. The question, I believe, is what are my thoughts on RAF type of technology? So it's really interesting. I was extremely excited when I first heard about it, and I thought it'd be great. The limitations are obviously, as I just mentioned, that how do you integrate your developers in that process? It really only going to work with your custom code that you're writing. You're not going to protect all your applications. If you're buying any commercial off-the-shelf application like Oracle HR Online or other applications out there that take a ton of time to update and patch and keep maintained, a WAF is really the only way to do that properly. And then, putting that burden on your development team to integrate it with everything they're doing, again, it's taken away from what, they really should be doing, which is, developing the code and testing and validating and making sure that they're developing it securely. So I like RAS technology maybe for code validation as you're writing it, making sure it's secure. But when you're deploying, really having that WAF that can go in any environment, anywhere, I think is a better model overall.
One more in. Let's see here.
Okay. We were managed to include the standard security requirements as non-negotiable on the front end. Is that a rarity? Yeah, I would say that's a rarity. So, I mean, you can tell companies that they need to develop, security requirements, and obviously, I think any third-party risk is now asking that. Are you developing secure code? Are you validating it? But that's one portion of security. You're not truly validating their program and making sure they're doing it. You're asking them the question, are they doing it? And they're just saying yes in the checkbox. So, putting in your contractual language, it's great. It also helps to understand if they're doing the right things, if they're a mature company and coding securely. But it's not a replacement for validation on your end. So as the old adage goes, trust but verify, right? So trust that they're going to develop secure code, but assume that you still need to monitor and protect against it. So it's great to have it in there, but if I don't have my own tools watching and validating, that's a real issue. I even think, if you are looking at other SaaS vendors and you have somebody else providing an application as a service, we can get in between them as well. And any customers going to that SaaS-based application, we can also validate and protect. So, having that second line of validation and protection, I think, is a really important feature. But yeah, I still agree. Yeah, you should try and get any company you're doing business with to make sure that they have secure coding practices and they're developing in appropriate manners. I believe we're at the end of the hour. Thank you very much for joining us. And, I hope that this has brought up some good questions and hopefully answered some questions for everyone.
Thank you so much, Serge and Jeremiah, for your great presentation, and to ThreatX for sponsoring this webcast, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcast. Until next time, take care, and we hope to have you back again for the next SANS webcast.